In ALEKS, they ask you to find solutions in an interval for the basic tangent, cotangent, secant, and cosecant equations. So they're going to give you, they ask you to find all the solutions for the equation in the interval of 0 to 2 pi. So remember, this bracket means that 0 is part of the solution. The parenthesis means that 2 pi is a boundary, not part of the solution. So your answer is going to be for anywhere from 0 to 2 pi, but not including 2 pi. All right, and they ask you to write your answer in radians, which means you're going to give your answer in terms of pi. If there's more than one solution, separate them with the commas. Okay, so we're going to use our special triangles. That's the method I'm going to use, show you how to solve these. It's not the only way you can do these, but I like this method because you can use it in lots of different ways and you have less things to memorize. Okay, so here, secant of, and one thing I forgot when I wrote down that question was the theta. So secant of an angle theta minus the square root of 2 equals 0. Okay, so the first thing we want to do is we want to get secant of theta by itself on the left side of the equation. So we want to move the minus square root of 2 over. So we do that just like if it was minus 3. If it was x minus 3, you would add 3 to both sides to get x by itself. Same idea here. So we're going to add the square root of 2 to both sides, and we get secant of theta equals the square root of 2. Now remember, secant is the reciprocal of cosine, and cosine is x over r, so secant is r over, we're going to think of this in terms of as r over x. And so we're saying we're going to rewrite this as a fraction, square root of 2 over 1. So r is going to be our square root of 2, and x is going to be 1. Now remember, r's, in this case, r will always be positive. The x and y's could be positive or negatives, depending on what location they are in. So if x is positive is in this direction, so we're going to draw triangles in quadrants 1 and quadrant 4. Okay, so I'm just going to draw a generic little triangle here, and then we're going to fill in some values, and one in here. Oops. Okay. So we need to find these reference angles for these triangles, and in this first case in quadrant 1, our reference angle is also our answer. In quadrant 4, this is our reference angle, and we'll have to use it to actually find the angle that we're looking for, which starts at the 0, rotates all the way around to this terminal side here. Okay, so we know that r should be the square root of 2, and x is 1. Okay, I'm just going to remind you, I did this in a previous video, but we're going to have some special triangles we're going to be dealing with. 45, 45, 90, which would be pi over 4, would be like 45. Okay, and remember we're going to use the legs as 1, 1, and the hypotenuse would be the square root of 2. And then we're going to have a 30, 60, 90 degree triangle. Opposite the 30-degree angle would be the 1. Opposite, the hypotenuse is always double the short leg, which is always opposite the 30-degree angle. And the long leg is the square root of 3 times the short leg. So it's going to just be 1 square root of 3 or 2. And remember, 30 degrees is the same as pi over 6. And 60 would be like pi over 3 when we're talking about radians. Okay, so if you keep these in mind, that will help you to do these pretty quickly. Okay, and also knowing this information, what is secant in terms of x, y, and r. Okay, so we can see here that we have in this case, this would be when we were not given a y value, so y could be 1 or negative 1 in this case, once we determine which triangle we're talking about. And I knew I had 1 and square root of 2, so I knew it was a 45, 45, 90 degree triangle, or reference angle pi over 4. Okay, so both of these have reference angles of pi over 4. Now remember, in quadrant 1, our answer for theta is our reference angle, pi over 4. In quadrant, in quadrant 1 is pi over 4. In quadrant 4, we need to take 2 pi and subtract our reference angle, pi over 4. And so we multiply 2 pi by 4 over 4, we get 8 pi over 4 minus pi over 4, and that's 7 pi over 4. And that is our other answer. And they ask us to separate our answers with commas. So that's what I'll do. And this is your answer for this equation, secant of theta minus the square root of 2 equals 0. Then theta is either pi over 4 or 7 pi over 4. That's the values that would make that equation true. So let's look at a couple more examples. So in this case, my equation, again, I've got to solve it. So the first thing I'm going to do is add 1 to both sides. And then I need to get rid of the square root of 3 because my whole goal, remember, is to get tangent of theta by itself. And I'm not going to rationalize the denominator because that's not my goal to find this. My goal is to find out what angle makes this equation true. So what angle, when I take its tangent, gives me 1 over the square root of 3? Well, tangent is y over x. So my y value could be 1, and my x value could be the square root of 3. But you also want to consider the case for y over x if these were both negatives, because a negative 1 over a negative square root of 3 would still simplify to give me a positive 1 over the square root of 3. So you want to consider both of these cases. So we're going to draw our little triangles, and we're going to go over here, and let's see, if x is positive, we're going in this direction, and y is positive, this direction, we're in quadrant 1. So we have x is the square root of 3, and y is 1. Okay. Now, what is our, can you tell what special triangle this is? I'm going to just go back over here. And we can see, hey, there's our 1 and our square root of 3 for the legs. So I know it's a 30, 60, 90 degree triangle. Remember that the 30-degree angle is always opposite the 1. Okay? So I'm going to go back to my problem here. So this would be like 30 degrees, but we're doing radians, so I'm going to write this as pi over 6. Okay? That's my one case. And that's actually your answer. Theta equals pi over 6 in quadrant 1. And then, let's see, I have two negatives here, so a negative x. So that would be over here, negative x, and a negative y. Okay, negative x and a negative y, that's going to be in quadrant 3. Okay, and so this reference angle is still going to be the same, pi over 6. Now, how do I find this angle here? So if I take pi and I add pi over 6 to it, that gives me that entire angle to this terminal side here. So this is going to give me pi plus pi over 6. So if I multiply pi by 6 over 6, gives me 6 pi over 6 plus pi over 6. I have like terms, I can add them together. That gives me 7 pi over 6. And there is here are my two solutions. These are the two values for theta. If I plug them in, that will make this equation true. Okay, let's look at another example. Cosecant of theta equals a negative 1. Okay, well, cosecant, we know, is the reciprocal of sine, and sine is y over r, so cosecant is r over y. Now remember, r has to be positive, so this is going to be 1 over negative 1. I can rewrite negative 1 as a fraction. I'm going to put the negative down in the denominator because I want the r value to be positive. So there's no other way to look at this. I can't make y positive, so let's look at this. Y is a negative 1. Anytime y and r are the same length, it's going to be on one of these axes. Okay, so y is going to be a negative 1. That's going to go down to here. My x value is going to end up being 0, by the way, because if r is the same length as x, I can't make a triangle out of it. Okay? And so we're just basically talking about this is our terminal side. We want to know what this angle theta is here. And this is going to be, remember, this is 0, pi over 2, pi, 3 pi over 2. So theta is 3 pi over 2. The more you do these, the easier they get. Okay? So look through several examples when you're looking at Alex. Try a couple, and go ahead and then get started. Okay, just one more quick example here. Tangent of theta plus 1 equals 0. I get tangent of theta by itself by subtracting 1 from both sides. I get tangent of theta equals a negative 1. Remember, tangent is y over x. And I want to rewrite this as a fraction, so I could write this as a negative 1 over 1. But I also could have written it as 1 over negative 1, because x and y both could have been the negative. So in this case, I'm looking at if y is the negative and x is positive, or I also want to consider the case when y is positive and x is a negative. So let's go look at both of those cases. So here we have, so I'm going to look at this, x is 1 and y is a negative 1. That is going to be x is 1, y is a negative 1. I have my reference angle here. Okay, so I'm going to look for this angle here, theta. So 1, 1, when the legs are the same, that for x and y, that's a 45, 45, 90-degree triangle, or a triangle with reference angle pi over 4. Okay? So for this one, I'm going to do 2 pi minus pi over 4. So we multiply 2 pi by 4 over 4 and gives me 8 pi over 4 minus pi over 4, and that's 7 pi over 4. That's one of my answers. Now let's go ahead and look at, I'll change that. This second case, so if x is a negative 1, it's out this way, and y is a positive 1, it's going to be up, oops, pretend like that's a straight line. Here's my reference triangle. Okay, so I'm going to have a pi over 4, same thing. This is 45, 45, 90, so pi over 4 reference angle. That is supposed to be pi over 4. And we're looking for this angle here. So that's going to be pi minus pi over 4. So we multiply pi by 4 over 4. And 4 pi over 4 minus pi over 4 is 3 pi over 4. And those are your two answers.